Hi all, let's go ahead and get started with our video for today. So first one I'm going to be working on is number 3. I've already identified the A, B, and C value. I want to identify the y-intercept for number 3. Well, that y-intercept is 0, C. In our case, it is 0, -10. Okay. To find the axis of symmetry, I do opposite B. So 3 over 2 times A, which is going to give me 3/2. So remember that the axis of symmetry is also the x value of our vertex. Okay. So now what I have to do is I've got to take that 3/2, substitute it back into the equation so that we can find the y value. So right here on the bottom, what I've done is I've kind of just made me some boxes that I can do the work in, because there's not a lot of room to write up there. So I'm going to have 3/2 squared minus 3 times 3/2 minus 10. Okay. All right. 3/2 squared, I am squaring everything inside the grouping there. So I'm going to have 9 over 4 minus, this is not both of them in the grouping, so I've got to do numerator times numerator, denominator times denominator. So minus 9 over 2 minus, and I can put this as 10 over 1. Now, before I can add or subtract those or combine those, I need to have a common denominator. So I'm going to multiply this middle one by 2, so I can get the common denominator of 4. And this third term, I'm going to multiply it by 4. So I will have 9 over 4 minus 18 over 4 minus 40 over 4. Nope, not over 40. 40 over 4. Hey, just noticed that I put 14 here. I didn't mean to put 14 there. Did mean to put 4 there. Okay. So now, combining those three, I get -18 minus 40, or 9 minus 18, however that you want to do that. Okay, so 9 minus 18 would give me -9. Minus 40 would give me -49 over 4. Okay. That cannot be reduced, so that will be the output for the vertex. Okay. So for our vertex, I just wrote it, -49 over 4. All right, now to create a table, even though it seems tricky, it's really not impossible. Okay, so let's go ahead and think about our table, do what we always said, put our vertex in the middle. If you want to write this as a decimal, you can. I'm going to leave it as it is, 3 over 2. And -49 over 4. Okay. This one could also be written, like I said, as a decimal, so I can see what numbers are around 1.5. Well, a number smaller than 1.5, it doesn't have to be a decimal. I could use 1. 1 is smaller than 1.5. And since it's a half smaller, I can go a half larger, and that would be 2. Okay, take those values, substitute them into the equation. Okay, so looking at equation 3, I'm going to pick up a pink highlighter here so we can see it. Everywhere there's an x, I'm going to substitute in 1. So 1 squared is 1. 1 minus 3 is -2, and -2 minus 10 is 12. -12. So we have -12. Well, these two should match when I plug in 2. So let's try that. 2 squared is 4. So if I do 2 squared, that's 4. Minus 3 times 2, minus 10. So 4 minus 6 is negative 2. Negative 2 minus 10 is also negative 12. So that does work. Okay? All right, I want you to try at least one more of these on your own, whether it be 2, 4, or 5, okay? So you can pick any one of those to try on your own. Now I'm gonna go down to number 8. Okay, number 8. This one here wants me to either determine whether it has a maximum or a minimum. Looking at this equation, the first thing I see is that it is not in standard form. By that I mean that my x squared term is not first. So I'm going to take this as my a term. Here's my linear term or the b term, and then this is my constant. So I'm going to rewrite it so that I can see it in standard form. So I have negative 4x squared plus 2x minus 5. Okay, you don't have to do that, but if you don't do that, make sure that you understand which one is your ax squared term. Okay, it is that one. That a value is what tells us whether this graph is going to open up or open down. Since it's a negative a, this one is going to open down, which means at the turning point, it's going to have a maximum. Okay? All right, so to find the vertex first so that we can find the domain and range, I'm going to take opposite b over 2 times negative 4. So I will have 2 divided by 8, or 1/4. So on the vertex of this one, I've got 1/4, or 0.25. Now I need to substitute that back into the equation. Again, it doesn't matter which order you use. So if I wanted to just keep it in the current form that it's in, I could do that, okay? Or I can use the one that's in standard form, all right? If you're thinking, hey, I want to make sure I don't make a mistake, okay, so then plug it into the original one. 2 times x minus 5 minus 4 times x squared. So then I've got 1/4 and 1/4. Now remember order of operations, okay? So 2 times 1, I can go ahead and simplify this term. That gives me 2/4. Okay, which also reduces to 1/2. Then I have negative 5. Negative 4 times 1 divided by 4 gives me negative 1. Oops, see, that's what happens when I don't pay attention. This one here, I have to do the exponent first. Okay, we've got to do the exponent first. So then we're going to have negative 4 times 1/16. Square of 1 and the square of 4. Now I can multiply those two. Okay. So I have 1/2 minus, I'm going to just leave it as a 5 for right now, minus 4/16. All right, now I've got to look for that common denominator. And I can see that 4/16 can be reduced if that doesn't go away. So I really can have 1/2 minus 5/1 minus 1/4. Okay, just by reducing that 4/16. So now I've got to have a common denominator. My common denominator is going to be 4. So I need to multiply this guy by 2, this guy by 4, and the third one, the third term, is already has a denominator of 4. So I've got 2 over 4 minus 20 over 4 minus 1 over 4. Okay? So that comes out to negative 19 over 4. All right, so negative 19 over 4 is my y value of the vertex, or the output value of the vertex. Okay? All right, and then number 10, I just want you to tell me everything that you can just by looking at that graph, whether it opens up, opens down, number of solutions, what are the solutions, the vertex, the axis, the symmetry, everything that you can think of to tell me on number 10. Okay? All right, so let's jump over to the packet that you guys have for today. Okay. All right, here's a couple of things that we're going to be working on tomorrow. You do not have this on your paper, and that's okay. I just kind of wanted to show you some of the things that we're going to be doing going forward. So we are going to be talking about the diamond method for factoring. Almost, if you notice it, it's like that area model that we talked about in class, but the box is just kind of tilted. So what I'm looking for is I'm looking for two numbers that will multiply to the top value and add to this bottom value. Okay, and what are these two factors that make that possible? So for example here, what two numbers will multiply to 24 but add to 10? Well, I could do 1 times 24, but they do not add to 10. Okay, so what if I did 2 times 12? Do they add to 10? No, they actually add to 14. Okay. What if I did 3 times 8? Because they would multiply to 24, but do they add to 10? Nope. Okay, what if I did 4 times 6? Those two there would work, okay? 4 times 6 does multiply to 24, and it does add up to 10, okay? Number 2, let's see, two numbers that multiply to 32, but add to 18. Multiply to 32, but add to 18. Well, again, I could look at 1 and 32, or 2 and 16. I could look at 4 and 8. I could look at, let's see, am I missing anything? All right, so looking at these three ordered pairs, or these three factor sets, which one would add up to 18? Well, that would be 2 and 16. So those would be the values that I place here. Okay, I would like you to try number 3. Tell me what two numbers would multiply to 18 but add to 9. Okay, all right, so on our new section of notes, we are talking about trinomials and binomials that are perfect squares. Okay, these have special factoring rules. In order to use these rules, the first and last terms need to be perfect squares, and the middle term needs to be twice the product of that square. Okay, or the square roots of the first and last term. I know that sounds wordy, so let's just look at it, okay? So we are going to kind of walk through some of these right now, but then tomorrow we'll definitely be talking about those shortcuts. Right over here, what I've put is I put the perfect square values, okay? So that you know what I'm talking about when I get the perfect squares. Like, what is the square root of 4? Well, that's 2, okay? And what's the square root of 9? Well, that's 3, all right? So we are going to be looking at those ones to see what we can come up with. So this first one, I want to look at first to see, in order to use these rules, the first one has to be a perfect square and the last one has to be a perfect square. Is x squared a perfect square? Yes, because the square root of x squared would be x. Okay. Is the last one a perfect square? Yes, because the square root of 64 is 8. Now, the next piece, it says the middle term needs to be twice the product of the square roots. Okay. So this first one, the square root of x squared would be x. The square root of 64 would be 8. So their product is 8x. Now, if this middle one is twice the square root, twice the product, so 2 times 8x. Well, 2 times 8x is 16x. Okay, if that's true, we can use a shortcut formula, right? So let's look at what this shortcut formula is, okay? So we are going to be using, a squared plus 2ab plus b squared. That's what we currently have, okay? The square of the first term, okay, the square of x squared, 2 times the product of the square root of a and the square root of b, and then b squared. If we have those, our shortcut is going to be, if we were to take a plus b times a plus b, we would get the same thing twice, so that's a plus b squared. Okay, so that's how we would find our answer on that one. So on this one, I would say that a is equal to x, b is equal to 8. And my answer would be x plus 8 and I squared. Okay. Now, I'm going to go through, though, on this one, and I'm going to actually check it to prove to us that that's true. So if I wanted to make sure that it's going to come out to what I said, could I do x plus 8 times x plus 8? Okay, x times x is x squared. X times 8 is 8x. 8 times x is 8x. And 8 times 8 is 64. These two combined, and I'd get x squared plus 16x plus 64. Okay, so that shortcut does work on that one.